On the 22nd of June, 1941, Soviet soldiers abandoned their tanks directly in military parks, without even trying to start them. It was neither panic nor cowardice. These machines were so hopeless, so ridiculously useless, that commanders preferred to leave them to the Germans rather than waste time on evacuation. We are talking about the T-27 Tankette, a Soviet design intended to make every infantryman a fearless warrior in armor, but which became living proof of how badly one can err in weapon design. This is the story of a machine that could not drive and shoot simultaneously, that caught fire from the slightest hit, and whose two-person crew sat so tightly that the mechanic and the gunner literally rubbed elbows. Welcome to the story of the most absurd idea in Soviet military engineering. Everything began with a beautiful dream. After the First World War, when the first tanks appeared on the battlefields, French and British generals came up with a seemingly brilliant idea. If heavy tanks are effective at breaking enemy lines, and light French Renault FT-17 tanks support infantry perfectly, why not go a step further? Why not create a machine so small and cheap that practically every soldier could be equipped with one? French Colonel Jean Estienne and British Major Giffard Le Quesnel Martel dreamed of an army of armored infantry replacements, of miniature combat machines with a single or two-person crew. They were named Tankettes, a diminutive of the English word tank. It sounded wonderful on paper. In reality, it was the beginning of one of the most absurd experiments in military history. In the mid-20s, a veritable tankette boom began. Every significant country wanted to have its own miniature death machine. The Soviet Union, fresh out of the Civil War, also decided to enter this race. The problem was that the Soviets had no idea how to design anything. Already, in 1919, an engineer named Maximov proposed a design for a combat machine called the Motonoska. Two variants, both equally hopeless. The first weighed 2 60/100 tons, had an engine with 40 horsepower and 8 millimeters of armor, which meant that any rifle would penetrate it. The second variant was even funnier. The driver was supposed to lie on his stomach inside the machine. Of course, neither project was realized, because during the Civil War there were more urgent matters than building toys for the Army. The idea was revisited in the late 20s. On the 2nd of June, 1926, the command of the Red Army adopted a 3-year tank building program. Within its framework, it was planned to produce so-called support machine guns, that is, tankettes. A whole battalion of such machines was to be assigned to a rifle division during the breakthrough of fortified enemy defenses. The formation was planned to be completed by December 1930. Soon after the program was adopted, the main design bureau of the arsenal began designing a single-seat light combat machine under the name Lilliput. The name perfectly reflected the size and capabilities of this design. The project required the creation of a special chassis and engine, so it was quickly abandoned as too complicated. Instead, it was decided to use ready-made elements from the MS-1 tank. A tankette project was created under the Index T-17, developed under the direction of Shukalov with the participation of Zaslavsky. The defense of the project took place on the 3rd of March, 1928, and the prototype was produced at the Leningrad Bolshevik factory only in the autumn of 1929. The armored hull was borrowed from the previous rejected project, which is why the T-17 was often called the Lilliput. The riveted hull consisted of armor plates with a thickness of 7 14 millimeters. The driver and gunner sat in the cabin. The Degtyaryov tank machine gun was mounted in a spherical socket slightly to the right of the machine's longitudinal axis. The ammunition supply was 1,500 rounds. A variant armed with a 37mm cannon was considered, but it was quickly abandoned because the machine was simply too small. Terrain observation was conducted through an observation slit in the front sheet of the cabin. During travel outside of combat, the front plate could be folded up on hinges. A door in the rear wall of the hull, closed by a hinged cover, served for entry. To increase cross-country capability, especially when crossing trenches, a tail with a length of 1 meter was attached to the rear of the hull. The length of the Tankette with the tail reached 3 70/100 meters. A 2-cylinder air-cooled engine with a power of 20 horsepower, designed by Michelin, served as the power unit. This was practically half of the engine from the MS-1 tank. The engine and transmission formed a common drive block. A simple differential gear was used as the steering mechanism. The fuel tank capacity was 47 liters. The drive system allowed the Tankette, with a mass of 2 25/100 tons, to develop a maximum speed of 18 kilometers per hour. The Tankette was tested with a run in January 1930, and then again after mounting lightened tracks in June. It showed better mobility than the light MS-18 tank. At the same time, its obvious flaw was the impossibility of driving the machine and firing the machine gun simultaneously by a single crew member. Furthermore, the unreliable operation of the transmission was revealed. Serial production of the Tankette, which was planned to be developed at the Stalingrad tractor plant, was deemed unprofitable. In the years 1930 to 34, it was planned to produce 1,000 units. Soon, a decision was made to continue work on a 2-seater Tankette using standard nodes of the T-18 tank. The Soviets finally understood that they could not construct anything decent themselves. They needed foreign help, and here begins the true story of the Soviet T-27 Tankette, a machine that was supposed to bring victory, but brought only shame and death to its crews. In 1930, the Soviet leadership made a desperate decision. Since their own engineers could not create anything sensible, it was necessary to buy a ready-made design abroad. A special purchasing commission was formed under the leadership of the head of the Directorate of Mechanization and Motorization of the Red Army, Alexander Kalinsky. The first country the commission reached was Great Britain. The greatest interest was aroused by the Vickers Armstrong's company, where, according to the program approved in Moscow, it was planned to acquire samples of Tankettes and a small tank. The problem was that the company strictly refused to sell single examples, especially with documentation. As a result of negotiations conducted by a representative of the Arcos Trading Company with the company's management, 20 Carden Lloyd Mark VI Tankettes and 15 light tanks were purchased. The Tankettes were to be delivered from May to September, 3 to 5 machines per month. Each cost the Soviet Union 275 pounds sterling, that is 7,250 rubles. This was a fortune for those times. The first machines reached the Soviet Union even before the return of the Purchasing Commission at the end of May 1930. All 20 purchased Tankettes were distributed among military districts and factories. 2 of the last 3 Tankettes, along with a complete set of documentation, were sent in August 1930 to the second plant of the All-Union Auto Tractor Association. According to the task of the Directorate of Mechanization and Motorization, the plant was to modernize the British machine and prepare for its serial production. To this end, a design group consisting of 5 to 6 people was created under the leadership of Nikolai Kozyrev. The possibility of installing a Type A engine instead of a Type T engine was tested by specialists from the Scientific Automobile and Engine Institute, where one English Tankette also arrived in July 1930. Since the automobile factory in Nizhny Novgorod was just being built and was not yet producing engines, it was planned to purchase 690 such motors abroad in the years 31 and 32. On the 13th of August, 1930, at a meeting of the Revolutionary Military Council of the Soviet Union, the second plant was definitively designated as the main one for the production of tankettes. In the same month, in the experimental design and mechanical department of the Bolshevik factory, with the participation of Nikolai Kozyrev's group, a review of variants for refining the English tankette in accordance with the requirements of the Directorate of Mechanization and Motorization took place. At the same time, a decision was made to continue work on the earlier project, but now in a tracked version and modeled after the English machine. Despite partially retaining the old designation, it was already a completely different design. The first prototype with a Type A engine and a hull made of ordinary steel was produced on the 3rd of November, 1930. During testing, to save time, they transferred the tracks and drive wheels from the English machine. However, the result of the trials proved cheerless. The engine overheated non-stop, the fuel supply was insufficient due to the small capacity of the tank, and the anticipated armor with a thickness of 4 to 7 millimeters was deemed ridiculous and insufficient. In a word, the refinement of the machine had to continue. At the beginning of 1931, a second prototype was produced at the second plant with a new hull and chassis, reinforced armor, and an enlarged engine. In this form, the Tankette was accepted into the armament of the Red Army by a decree of the Revolutionary Military Council on the 13th of February, 1931, under the designation T-27, even though the state tests of the machine had not yet been completed by that time. This was typical Soviet practice, the rush to fulfill the plan without regard for the consequences. A completely untested machine went straight into serial production. The layout of the Tankette was characterized by the combination of the driving compartment with the combat and engine compartments. At the same time, the transmission compartment was located in the front part of the hull. The mechanic driver's seat was located on the left side, and the gunner, who was also the commander, sat to the right of the engine placed in the middle of the hull. For thermal insulation and protection of crew members from burns, the engine was covered with a hood made of 2 metal plates with an air layer between them. Behind the gunner's seat, on 2 brackets, the storage battery was placed. In the driving compartment, in front of the mechanic driver, the steering lever and pedal shaft were installed, on which 3 pedals were mounted: clutch, foot brake, and gas. Between the mechanic driver's legs was the gear shift lever. Below, under his left hand, was the slider for the cable drive of the shutter in the radiator, located in the rear part of the hull. Behind the mechanic driver's back, a box for tools and spare parts was installed. 2 more boxes for parts were fastened to the outside of the machine. The Tankette's armament consisted of a 7 6200 millimeter Degtyaryov tank machine gun, the ammunition supply of which included 2,520 rounds. The standard mechanical sight of the machine gun was used for firing. On machines of the first year of production, the machine gun was installed on a special bracket that provided vertical aiming. Horizontal rotation of the machine gun was carried out by rotating the mounting fork in the bracket. On tankettes of later series, The machine gun was installed on a special flange providing convenient guidance both vertically and horizontally, as well as better protection for the gunner from bullets and shrapnel. A peculiarity of the Tankette was the placement and feeding of the ammunition supply. 40 rifle magazines were located in the side boxes of the hull. Stacking of magazines could be carried out according to two variants. In the first case, magazines were stacked in 2 rows of 10 pieces in the feeding mechanism in each box. Feeding of magazines was carried out using a crank and a cable drive spool. Along the longitudinal axis of the hull in its central part, with the flywheel facing forward, a 4-cylinder, 4-stroke carburetor inline liquid-cooled engine with a power of 40 horsepower at 2,200 revolutions per minute was installed. The working volume of the engine was 3,060 cubic centimeters. Starting the engine was done using a starter with a power of 9/10 of a horsepower or manually with a crank. The fuel tank capacity was 42 liters. Gasoline supply was by gravity. The cooling system included a thermosiphon centrifugal pump, a 4-blade fan with a belt drive from the crankshaft, and a radiator with a steam air valve. The capacity of the cooling system was 22 liters, which was not enough anyway, because the machine constantly overheated. The chassis consisted of 6 identical rubber-coated road wheels per side, blocked in pairs and 3 oscillating bogies mounted on a longitudinal support beam. There was also a wooden beam with a steel guard, a drive wheel in the front position with a non-removable gear ring, and an idler wheel with a track tensioning mechanism and spring suspension. The fine link track with lantern gearing, with a width of 150 millimeters, consisted of 129 links with a pitch of 44 millimeters. The electrical equipment of the machine was made according to a single-wire scheme with a voltage of 6 volts. External and internal communication means did not exist in the machine. Communication between individual machines in a subunit was maintained using signal flags, which in combat conditions was simply absurd. Serial production began in the year 1931. The first 45 machines were produced by the Bolshevik factory, and the following year production continued at the second plant. From the year 1932, plant number 37, named after Ordzhonikidze, also began assembly. The assembly of hulls was handled by the Cracking Electric Air Mechanical plant in Podolsk, which received armor plates from the Azhora plant. In the process of serial production, attempts were made to improve the design, but every modification only worsened an already hopeless situation. Soviet engineers apparently could not accept the fact that they had created a completely useless machine. Instead of admitting defeat, they decided to make it even worse through successive modifications. In 1932, the Design Bureau, under the leadership of Daring, together with the second plant, designed a version designated as 44. It represented the base Tankette with a rotating turret and improved suspension. The structural scheme did not differ from that applied in the base model. In the autumn of 1932, a representative of the Directorate of the Chief of Armament of the Red Army, Engineer Kozhevnikov, developed a hydromechanical transmission for the Tankette, which remained only on paper. At the same time, on the initiative of the Design Bureau of the compressor plant, under the leadership of Lebedev, experimental work was conducted on the installation of fenders over the tracks, fastening of shovels and tools, and the installation of a special filter to prevent poisoning of tankers by gasoline vapors and exhaust gases. Mention should also be made of the use of the Tankette as an experimental machine in tests of a special protective screen against attacks by dogs planting explosive charges. It consisted of 4 metal nets made of 1 mm wire that were under voltage, which prevented dogs with explosives from jumping onto or crawling under the tankette. The nets were attached to the machine and powered from its electrical system. Practically immediately after the start of serial production, designers proceeded to work on creating various combat and auxiliary machines on its basis. Already in November 1931 at the Bolshevik factory, together with the main design bureau, a project was developed to install a 20 mm anti-aircraft automatic gun instead of the machine gun. The horizontal aiming angle of the gun was 10 degrees. The elevation angle plus 15 degrees. The rate of fire 130 to 135 shots per minute. The tabular firing range 2,000 meters. Magazine feed was 20 shots each. The set included fragmentation and armor-piercing shells with an initial velocity of 845 and 715 meters per second, respectively. The project of this anti-tank Tankette was not realized, probably due to the withdrawal of this gun from production and armament. Speaking about self-propelled artillery units created on the basis of our heroine, first of all, one must stop at 2 machines designed by the head of the tank department of the Bolshevik factory, Sergei Ginsburg. The first of them was distinguished by a slightly changed armored hull and chassis. In the armored hull of the machine on the right side, a 37 mm cannon was installed, protected by a shield with horizontal guidance angles in a sector of 18 degrees and vertically in a range from -5 degrees 15 seconds to +9 degrees 10 seconds. Above the cannon, in an autonomous installation, a machine gun was placed. Due to the small armored volume of the machine, most of the ammunition supply was transported in a special track trailer. This was simply ridiculous. An artillery piece required a separate trailer with ammunition. The chassis of the machine, with respect to one side, consisted of 3 bogies with 2 rubber-coated road wheels each. The front bogie was oscillating with an axis in the frame of the tracked drive. The 2 rear bogies were connected by a spring into a bogie attached to a transverse tube. 2 rubber-coated support wheels of small diameter were suspended on a leaf spring. The machine had duplicated controls from the commander's seat. Armored protection and mobility characteristics remained the same as in the base machine. The prototype of the self-propelled unit was produced at the Bolshevik factory in April and May 1931. During tests conducted at the Scientific Research Polygon, numerous deficiencies were detected. In particular, the impossibility of using the cannon sight for firing the machine gun, undeveloped placement of ammunition, unsuccessful design of the armor of the engine cooling system radiator, which led to its overheating, and difficult movement control from the commander's seat. The second specimen of the self-propelled gun differed from the first by the presence of only cannon armament and the design of the chassis. Due to the absence of the machine gun above the cannon, the height of the line of fire increased and, accordingly, the angle of inclination. The chassis had a semi-rigid suspension with leaf springs as an elastic element. On each side, 4 rubber-coated road wheels blocked in pairs and 2 bogies were installed, the axes of which were fastened in the drive frame. Compared to the road wheels of the base model, the wheels of the self-propelled gun had an increased diameter. The idler wheel was raised. Moreover, on each side there were 2 rubber-coated unsprung support wheels. A prototype of this self-propelled unit was produced, but numerous defects of the previous machine proved to be inherent in it. Further work on these units was stopped, which was the only reasonable decision in this whole story. In December 1931, the Directorate of Mechanization and Motorization of the Red Army approved the technical task for a small self-propelled gun with a 76mm dynamic reactive recoilless cannon of Kirchevsky's design on the chassis of our Tankette. This self-propelled gun was intended for operations within reconnaissance units and to accompany cavalry. It was developed in 1933 at the plant number 7, and in the same year they produced a prototype. The Kirchevsky cannon was installed instead of the standard machine gun near the right side of the machine, had a horizontal guidance angle of 5 degrees and a vertical one from -1 degree to +5 degrees. The initial velocity of the shell was 300 meters per second, the ammunition supply 30 rounds. The cannon was equipped with an automatic reloading mechanism. All its parts, except the nozzle and the carriage, were protected by 6 and 9mm armor. The engine, transmission, and chassis of the unit remained unchanged compared to the base Tankette. From the 15th to the 25th of April, 1933, the self-propelled gun was tested on the polygon of the Military Academy of Mechanization and Motorization, named after Stalin in Kuntsevo. During the tests, a rupture of the barrel occurred as a result of an explosion, and the tester conducting the firing was killed. After repair at plant number 8 in Podolsk, the vehicle was demonstrated to the command on the chemical polygon in Kuzminki on the 5th of August, 1933. But further work was ceased. Unlike the self-propelled guns, the flamethrower variant was built serially and was in the armament of the Red Army. The prototype was produced at the Moscow compressor plant, actually converted from a linear Tankette in December 1931. In the summer of the following year, the machine underwent trials on the Scientific Research Chemical Polygon of the Chemical Improvement Courses for the command cadre of the Red Army and was adopted for service. In the years 32 and 33, 187 Tankettes were converted into flamethrowers. On the basis of the linear version, an artillery tractor was also designed, which was used to transport light artillery pieces together with the crew. In the years 1932 and 33, under the leadership of engineer Koratnoshka, a supply vehicle was designed on the basis of the Tankette. It was intended for transporting ammunition to positions in the enemy's fire zone. It held 40 ammunition boxes, 80 zinc boxes with a mass of 808 kilograms, and 24 loaded rifle magazines. The supply vehicle differed from the base one by the presence of a self-unloading mechanism and a changed design of the side ammunition boxes. The basis of the design of the self-unloading mechanism was the principle of roller conveyors, that is, a roller conveyor belt, on the rollers of which, fixed at a short distance from each other, piece loads or loads and packages move. Switching on the unloading mechanism was carried out from the mechanic driver's seat. A prototype of the supply vehicle was produced in 1933. In 1934, a prototype mine layer was created, the main purpose of which was setting up minefields in the zone of rifle and machine gun fire directly before an enemy tank attack. The mine layer differed from the serial Tankette by the installation of special equipment for laying anti-tank mines. Dispensing mines was carried out using a special mechanism consisting of a drum with a cable and an anchor. During the movement of the machine, the anchor was dropped to the ground and hooked onto the soil. With further movement of the Tankette, the cable unwound and rotated the caisson with mines in the drum. Mines stacked in the caisson fell out through the exit opening in the drum under the action of their own weight. Mining could be conducted at any speed of movement. Mines were scattered in a single row with intervals of 90 to 110 centimeters. The drum was manufactured from 10mm armor and installed in the rear part of the machine between the ammunition boxes. It held 170 anti-tank mines. The time for mining was 16 to 20 seconds, and 45 minutes were spent on filling the drum. A serial combat machine was never produced. The small mass and dimensions of the Tankette also proved attractive for its use within airborne landings. In 1932, an example of a parachute system was produced for dropping it with a parachute. Since the mass of the Tankette significantly exceeded the maximum permissible load of the bomber, it was lightened by 344 kilograms by removing everything possible and even draining the water from the cooling system. The plane also had to be lightened. In December 1932, the system was tested at the Scientific Research Institute of the Air Force. It became the prototype for a large number of similar devices intended for landing light tanks, armored cars, and trucks. This was the only truly innovative thing related to this Tankette, although the very idea of dropping a 2-ton can on tracks with a parachute sounded just as absurd as the rest of this project. In 1933, the only export delivery of Tankettes to Mongolia took place. By that time, a separate armored tank regiment had been formed in the Mongolian People's Revolutionary Army. Its armament included 10 Tankettes delivered from the Soviet Union, as well as 10 armored cars. True, the T-machines did not participate in the conflict at the Khalkhin-Gol River. They were not in the composition of the 57th Special Corps from the 19th of June, 1939, transformed into the 1st Army Group. The beginning of serial production coincided with the development of the mechanized troops of the Red Army. A mechanized brigade in the new composition possessed 178 tanks, 32 fast tanks, and 91 T-27 Tankettes. In the period from 1933 to 35, the maximum number of these machines was counted in parts of the Red Army. They received their baptism of fire in Central Asia in battles with the Basmachi, where, despite everything, they managed better than could be expected. In 1933, 10 Tankettes were delivered to Mongolia. In the Soviet-Finnish War, the majority were transferred as tractors and transporters. The technical condition left much to be desired, and cross-country ability in winter Karelia was zero. In June 1941, all Tankettes in the border districts, 1,087 units, were abandoned in parks as having no combat value. The 7mm armor was penetrated by every rifle. A single machine gun meant nothing, and the speed of 18 kilometers per hour made them ideal targets. The Germans occupied them without a fight and did not try to use them. In the Far East, they stood in warehouses. In 1945, no one thought of using them against the Japanese. If you like this story, leave a thumbs up, write in the comments what senseless technology to describe next time, and subscribe to the channel.